Okay, question number 15 for the APGP looks interesting a bit. Let's try this. We won't be able to do the questions of APGP involving trigonometry right now, but after we do the trigonometry chapter, then we can try those as well. When we do the revisions and everything. So they've given you, mark out all the relevant proper information that you will need. So this is a GP as the first term A, you don't know the first term, and the common ratio R, you don't know the R as well, and the sum to infinity is S. They have not given you anything. A second GP has the first term A, so now there is another GP. A second GP has the first term A, common ratio capital R, and sum to infinity 2S. Show that R is equals to small r is equals to 2R 2 times capital R minus 1. So we have the first GP and we have the second GP. Always write down all of the things that you know. A, R, and sum to infinity is S. And over here, A is A, R is capital R, and sum to infinity is 2S. So if we form the equation or sum to infinity, it is A upon 1 minus R. And A is A for the first GP, and R is R, small r for the first GP, and sum to infinity is S. So this is equals to S. So this is, we have formed one equation. And now the sum to infinity over here, it is equals to A upon 1 minus capital R, because the common ratio for the second GP, it is capital R. 1 minus capital R. And we know that the sum to infinity of the second GP, it is 2S. 2 times S. So we have the second equation as well. And now what we would do? They're asking you to get another equation. Find small r is equals to 2 times capital R minus 1. So we would definitely solve them simultaneously. So we can see this is capital S is this A upon 1 minus small r. So I can replace this capital S over here with this thing. So this would become what? A upon 1 minus capital R is equals to 2 times, and instead of S, I would write the A upon 1 minus small r. And now we will move things around, simplify, and get the equation that they have asked us to form. So you can see the A and A will be cancelled out. And this 1 minus r will go over there and multiply. And this 1 minus capital R will go over there and multiply, cross multiply. So 1 minus small r is equals to 2 times 1 minus capital R. 1 minus r is equals to 2 minus 2r. What do we want? Small r to make the subject. So 1 minus 2 plus 2r. I moved everything on the left side. And I moved the small r to the right side. So this becomes minus 1 plus 2r is equals to small r. This is it. So sometimes the question is not very difficult. It looks difficult because they have not given you any value. You just had to solve them simultaneously and you got the equation that they asked you to form. Okay. Then it is now given that the third term of the first progression is equal to the second term of the second progression. So third term of the first GP, it is equals to second term of the second progression. So second term of the second GP. This is the information that they've given you. Express capital S in terms of A. Okay. So we would now be able to form another equation using this information that they've given you. So for the first GP, the third term will be AR power square. If you can recall, I told you the generalization of the terms. If the term is 3, then the power of R will be 2. If the term is 10, the power of R will be 9. 1 less. The power is 1 less. So for the first GP, first term is A and R is a small r. Okay. And then for the second term, for the second GP, it is A and capital R power 1. Because the common ratio for the second GP, it was capital R. Common ratio is capital R. Then they want to find S in terms of A. So we have this equation S in terms of A and R. We have to find, somehow replace this thing. Right? We have to get rid of this thing. So what can we do? What can we do? What can we do? If we can see that uh okay, third term is equal to the second term of the second progression. So A and A will cancel out. So R square is equals to capital R. So if I substitute this value of capital R over here, this capital R value over in this equation. So what would this become? Minus 1 plus 2 times capital R is small r square plus R. And now move everything on one side. So 2r square minus r plus, sorry, minus 1 is equals to 0. And now we can get the value of r. Quadratically, you can solve it. So 2 minus 1 and minus 1. So you're getting the value of r as negative half and r as 1. I told you r as 1. This is always not used because when your r is 1, then the terms won't change. Right? You're multiplying every time with 1, 1, 1, 1, 1. The multiplier is 1. So your terms won't change. So r is equals to 1. You will get rid of it. And so now your small r is negative half. So s, we know s is equals to a upon small r. So s is equals to a upon 1 minus negative half, which will be a upon 1.5, which will be 2 a upon 3. This is your answer for the second part. So yeah, any questions, anyone? This was a good question. So there was so much information in this question. So you have to set aside everything properly. Keep the things, everything in front of you, and you can make it easy. Okay, look, question number 17. This is also an interesting one. There are how many ways that they can use algebra in this, because there's nothing more over here. Only pure algebra using the formulas. Understanding the situation using the formulas. So the nth term of an AP, it is given to you. So they have given you the Tn formula. Nth term is 1 upon 2 3n minus 15. Find the value of n for which the sum of the first n terms is 84. So find n when sum of n it is equals to 84. So for the sum of the first n number of terms, you need the value of a, you need the value of d. You don't have it because it is an AP. So what would you do? Find a and d. Somehow find a and d using this Tn formula. And how can we do that? We know the Tn formula is a plus n minus 1 into d. So we can compare the equation that they have given you for the nth term and the equation that you have. If you expand your equation, you will have a plus dn minus d. So Tn formula for you, it would become a minus d plus dn, right? And this thing would now be compared with the equation that they've given you after expansion. So this would become 3 upon 2n, which would be 1.5n minus 7.5, right? 15 upon 2 is 7.5. So what do? You find the value of d and the value of a by comparison. So if you compare the coefficient of n, you can see it is 1.5. And the constant part, a minus d, is equals to minus 7.5. So you will get d as 1.5 after comparing the coefficient of n, and a minus d is equals to negative 7.5, and a is minus 1.5. You know the value of d. So A will be minus 1.5 would go over there and become plus. So this would become minus 6. So now you have the value of A, you have the value of D for this term. And now you would use the sum of the first n formula. So n term formula, which is n upon 2, 2A plus n minus 1 into D is equals to, they have given you 84. You don't know n. The 2 will move over there and multiply. Okay, so you can move this, the 2 over there. So 2 times A is minus 6 plus n minus 1 into 1.5 is equals to 2 times 84 is 168. And now you just have to solve this completely, get the answer of the value of n, get the answer for n. So n minus 12 plus 1.5 n minus 1.5 is equals to 168. Expand this, or first simplify. Minus 13.5 plus 1.5 n is equals to 168. Expand this would become 1.5 n square minus 13.5 n and minus 168. I'm moving the 168 on the left side. And use your calculator to solve this quadratic. 1.5 minus 13.5 and minus 168. So n is 7, which is not possible, and n is 16. So this is the answer. You cannot have a negative position, right? So n is 16. Okay? Any questions? This is also something which can be used comparison to get the unknowns. These are just different methods that they are using algebra to find something that you know that you would want, and then using those things then later on for the second part. Comparison. Copy it down or take a screenshot. Let's do another one. Look, questions like this, application based. Each year, the selling price of a diamond necklace increases by 5%. This is GP. This is the percentage they've given you. Increase by 5%. So your value of R will be 1.05. 100% plus 5%. So every year it is increasing. You can try these later as well. Look, question, over a 21-day period, an athlete prepares for a marathon. This is also application based. Question number 23 as well. Look at those two heavyweight boxers. There was one where they were hammering a nail. I want to do that one. That one was interesting. They were hammering a nail. A ball is dropped. I don't know. It was one of the recent ones, I think. It isn't over here. I think after 2022. So you have a lot of past papers to practice. Mm, 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 mm. Okay, let's do this one. This has a lot of information. So maybe there might be something over here which may be difficult. So two heavyweight boxers decide that they would be more successful if they competed in a lower weight class. For each boxer, this would require a total weight loss. They want to lose, both of them want to lose 13 kg. At the end of week 1, they have each recorded a weight loss of 1 kg. So, week 1, loss of 1 kg. The loss is a loss of 1 kg. And they both find that in each of the following weeks, their weight loss is slightly less than the week before. Okay. For boxer A, weight loss in week 2 is 0.98. So for boxer A, it is 0.98 now. He loses 1 kilogram in the first week, then loses 0.98 in the second week. This is your boxer A. It is given that his weekly weight loss follows an AP. So you will do the AP thing over here. Write down an expression for his total weight loss after X weeks. So total weight loss, we this means that total weight loss would be sum of the first sum of the loss in all weekends of all weeks. So total weight loss is the sum of n, right? So week 1 is your A. He is losing 1 kilogram in the first week. Then he is losing 0.98 in the second week. So you can see the difference. The D value is how much? It is minus 0.02. So in the third week, he will lose 0.96 kg because we have the D. Because they told us that this is an AP. And they have told us after the total weight loss after X weeks. So week X, we don't know how many weeks. Okay. So the sum of all of the weight losses in all of the weeks together will be the sum formula, for which your A is 1, your D is minus 0.02, and your N is X. We don't know N, how many weeks. So X upon 2, 2 times 1 plus X minus 1 into D. D is negative 0.02. This is the answer to your first part. So you understood the information properly, you read it properly, understand what is happening, and then you use the formula. That's it. He reaches his 13 kg target during N week. Use your answer to part 1 to find the value of N. So we want the sum to be the loss, overall loss, to be 13 kg. So now they have given you, this is the answer to the first part. For the second part, the sum of the first X, the weight loss is all of the weight loss. It is 13 kg. We wanted to lose 13 kg overall. So 2 minus 0.02x plus 0.02. So 2 would go over there and multiply. So 26 is equals to x. 2 plus 2.02 will be 2.2 plus 0.02 will be 2.02 minus 0.02x. Expand and move everything on one side. So this would become minus 0.02x square plus 2.02x minus 26. This becomes quadratic. So minus 0.02, 2.02 and minus 26. So your x is coming out as 85. I think maybe there's something wrong. Wait a minute. Wait a minute. Have I done something wrong? M minus 1 into D. Into D, yes. 2 times. Okay. 13 kg target. So 2 third 26 and minus 26. This is negative 0.02. 2.02 and negative 26. 15.1. I think 30. 15 is the closer one. So your one answer is 85.9 and another value of x is 15.1. So he reaches a 13 kg target during week N. So your week would be after the 16th week. In the 15th week, he has not reached his target, right? So x will be 16. So in the 16th week, at the end of the 16th week, he will have the total weight loss of overall 13 kg target. The target will be met. Let me confirm this answer as well. 27. Yeah, 16. Look. equate to 13 and then either simplify to a 3-time quadratic or find at least one solution, need not be equal to an unsimplified quadratic, and the answer is 16. Okay, good. Then boxer B's weight loss. Boxer B weight loss in week 2 is 0.92. So week 1 is 1 kg, week 2 is 0.92 kg, and it is given that his weekly weight loss follows the geometric. So now this is the GP. Calculate his total weight loss after 20 weeks and show that he can never reach his target. Okay. So what is the value of R? What your A is 1 and your R is T2 upon T1, right? The ratio, which is 0.92. 0.92 divided by 0.92 divided by 1 will be 0.92. So sum after 20 weeks. It was what? You will use the formula, the sum formula for the GP. It is 1 A 1 minus. When your R is between -1 and 1, this is the sum formula that you use. A 1 minus R power n upon 1 minus R. And so this would become 1 minus 0.92 power 20 upon 1 minus 0.92. And how much is this? You'll use your calculator. Power 20, 1 minus 0.92. 10 point. So he loses a total of 10.14 kilogram after 20 weeks. And then they have told you, asked you, show that he can never reach his target. So the sum to infinity. 1 upon, sorry, A upon 1 minus R. So A is your 1 upon 1 minus 0.92. So 12.5. So this means that your sum to infinity, if it is 12.5, he will never be able to reach the target of 13. Can never reach 13 kg loss. He is losing after infinite number of weeks. The total loss he can do, it is 12.5 kilogram, not of 13. So he can never reach his target, isn't it? समझ आया? Okay. Any questions, anyone? Rayan, Mohit, Sanchi.
No, sir.
Sanchi, all good?
Yes, sir.
Munib, Mohit. So look, the questions are not very, it looks difficult, but everything revolves around the same A, R, D, the sum formula somehow. So you can take a screenshot, or if you have any questions, ask, write it down. I'll give you 2 minutes, and then I will do one more question, then you people will do the next one. Okay. Okay. Mm, okay. 20 number 38 looks good. So the first two terms of an AP are 16 and 24. So term 1 is 16, second term 24. And this is an AP right now. Find the least number of terms for the progression which must be taken for the sum to exceed. So we want the sum to exceed 20,000. 20,000. So for this one, we can see the D. How much is the D? T2 minus T1, which is 8. So your A is 16 and your D is 8. And we want the sum to exceed 20,000. So let's see what will happen. Uh, so N, you don't know N upon 2 times A plus N minus 1 into D. And we want this thing to exceed 20,000, right? The sum to be more than 20,000. So what would you do next? N upon 2, this would be 32 plus 8n minus 8 more than 20,000. 2 can go over there and multiply. So this would become 24n plus 8n square more than 40,000. Move everything on one side. So 8n square plus 24n minus 40,000. And I told you what you do. You find the roots. This is a quadratic inequality. You have done this before. This is now quadratic inequality, and you know how to solve this. We want the least number of terms for it to exceed 20,000. So if you solve this quadratically, you will get the value of n when it is 0, exactly 0. You find for exact the roots. So 8, 24, and minus 40,000. So your n is coming out as minus 72.2 something, which cannot be possible. And when your n is 69.2. So you can, if you round off, because n, n is an integer, the number of terms is an integer. So this means the next term, n would be definitely 70 then. So the sum of the 70 terms, so first 70 terms would be just above 20,000. So if I form the equation using the calculator as well over here, so you can see x upon 2, which is 32 plus x minus 1 into 8. And now if I replace the value of, look, the value of n as 69, it is coming out as 19,872. And if I do it now 70, let's see, it should be more than 20,000. So look, it is more than 20,000. So this means that the least number of terms to be taken are 70, so that the sum exceeds 20,000. So this is your answer. Okay. Then a geometric progression has a first term. I'm just going to a geometric progression, the second part. The first term is 6, and the sum to infinity, okay, is 18. A new geometric progression is formed by squaring each of the terms of the original progression. Find the sum to infinity of the new progression. Okay. First of all, we find the d value, sorry, the r value for this one. So sum to infinity, we know the formula is a upon 1 minus r. So 18 is equals to 1, sorry, a is 6 upon 1 minus r. This would go over there and multiply. So 18 minus 18 r is equals to 6, and this would become 12 is equals to 18 r, and so your r is 2 upon 3. So this means the term 1 and term 2 and term 3, and I'm just finding out the terms. What would be? So first one is 6, then the next one would be 6 times 2 upon 3, which will be 4. Then again, this would be 8 upon 3. And now what are they doing? That they are forming a new geometric progression by squaring each of the term of the original progression. So if you square each of the term, so the new GP will be something like this. The term 1 would be 36, term 2 will be 16, term 3 will be 64 upon 9, something like that, and so on and so forth. So for this sequence, your A is 36 and your value of R is T2 upon 31. Oh, sorry, T1. 36 upon 30, sorry, 16 upon 36, right? 16 upon 36 is how much? 4 upon 9. Let's check the same if we get the same R from T2 and T3, T2 and T3. So T3 is 64 upon 9 upon 16. So look, your value of R is again constant. Common ratio is constant. And now they're asking you to find the sum to infinity. A upon 1 minus R. 36 upon 1 minus 4 upon R, 4 upon 9. So 64.8. This is your answer. Okay. Okay. I hope you people are understanding the questions that we're doing, and hopefully you will be also able to do the questions yourself as well. And for today's class, I think this is enough for the past papers that we've done. Okay, I'll give you now. You people will try the past papers, and I'm stopping the recording. If you have any questions in this one, ask. Stop the recording.